All right, so you hear me? Okay. Let's get started now. The first thing for today is we just have a few reminders. We have homework 1, which is not optional. And so you're going to need this for Wednesday's workshops. The next thing is that we also have milestone 0 coming up. And it's also due tomorrow at midnight. And if you guys still need teammates, you can use our search for teammates post on Piazza. And the last thing is, or one of the last things is at lunch. We are serving food to in-person students here, but we have this, like, because of MIT COVID policy, you have to eat outdoors. And so like you can't actually be eating indoors at any point during the day. This is just MIT policy. And if we don't follow this, we might not be able to serve food in the future. And also when you're outside eating, you should try to spread out as much as possible. This is also to prevent the spread of COVID. And finally, some people were confused about the theme there for this year, Imagine. Essentially, like, people were confused about how closely you have to follow this. And the idea is that our theme is more of a guideline on what your project should be. And all you have to really do when you're telling us is, when you're like presenting to us, is just explain how it fits in, like how Imagine is related to your project. Okay. And a bit of reminders, if you have any questions, you should go to our questions doc at weblab.to/questions. And we also have Buka Buka, which is a turtle that will cry if there's not a lot of questions asked. So please ask questions. All right, let's get started. So today we're going to be talking about JavaScript, and I'm going to first give a quick intro on JavaScript. And sure, let's get started. Okay, so from yesterday's lectures, we've learned about HTML, which is a core component of every website. So HTML, what it does is it describes the content and the structure of your website, what exists, where it is, how it's organized, all the cool stuff like that. We also learned about CSS, which describes the presentation of the website. So colors, fonts, margins, stuff like that, all the stuff that makes your website pretty. Now, when you have both of these together, what you get is like a very nice, pretty website. But the issue is that like these two together alone, they just make a static website. So you're not going to be able to interact with your website. You're not going to be able to do anything dynamic without what we're going to be learning about today, which is JavaScript. So JavaScript enables us to, it's a programming language that manipulates the content of a web page. And what this means is that, in other words, this takes HTML, CSS, and makes it interactive. So, so I'm talking about like buttons, or you click on a website, keyboard presses, stuff like that. JavaScript lets you like have your web page talk to the server. It lets you have stuff be interactive, stuff like that. And because of this, JavaScript is used by like a vast majority of websites and web apps. So if you've used pretty much any website before, it probably has some JavaScript in some form or another. And if you look at this code snippet here of JavaScript, it doesn't really matter what it actually does. But if you take a look at it, it kind of has like the vibe of a programming language, more so than HTML or CSS that we've looked at. And because of this, like JavaScript is where you actually do all the logic for your website, whereas HTML and CSS is more of like the structure of the website. And just like a side note is that JavaScript is not actually related to Java. It just shares in the name. And there's like a little bit of a story here, but that's for another time. All right. And so if you take the analogy of a body, of human body, your website is kind of like if you take the analogy between your body and a website, HTML is like the bones that provides the structure for your website. And CSS is like the skin. So that's like what you see. And then JavaScript in that analogy would be the organs and the muscles. All right. So now that we know about what JavaScript is, where can we run it? And there's two places that we can run it. The first one being the browser console, which if you follow the shortcuts here, you can be able to open on any of your browsers. And let me just show that real quick. And you can see like this is the console. There might be some errors. You don't have to worry about that. We can just clear it. And so this is where we're going to be doing some of our code today. And the other way that we can run JavaScript is tied to our HTML file. And what that means is pretty much it'll run like in the background. It's attached to our website. And I'll talk more about that later. Okay, so now we're going to get on to like kind of like the meat of this lecture, which is how does JavaScript work? So the first thing that you'll note about JavaScript is that there's 5 primitive data types. And they're relatively simple. We can go from like the simplest one, which is Boolean, which takes on 2 values, true or false. And then we have numbers, which encompass like everything you need to know. Like it encompasses everything about numbers. So like positive, negative, integers, floats, decimals. It can be, everything is like looped into just one type, which is a number. And then we also have strings, which are like sequences of characters. And you can have characters that are just, you can have like symbols, you can have numbers. You can also have an empty string. So these are just sequences of characters that are 0 or longer. And these are denoted by quote symbols. So you'll notice that every string here has quote symbols around it. And then the last 2 data types are null and undefined. Now, these might sound really familiar, but they're actually separate things. And I'll get more into that later on. All right, so one of the most basic things that you're going to be doing with these data types is you're going to operate on them. So these are going to work mostly how you expect. You can add numbers together, like 5 + 4 is 9, and so on. But what you can also do is you can add 2 strings together. And what this does is it just concatenates 2 strings together. So it just combines them into one without a space in between. And so these are like your arithmetic operators. We also have comparison operators, which take 2 data types, and then it returns a Boolean. So this should all make sense. 2 is equal to 2, that's true. Is 6 not equal to 7? That's also true. 15 is less than 11, that's obviously false. And so one thing that you'll know is that the comparison operators use triple equal signs here. This is like a quirk of JavaScript that you just have to remember, and I'll get into more about that later, because this might be different from other languages that you might be used to, which only use 2 equal signs. All right, so, okay. So I have here like a snippet of JavaScript code, and you don't really need to know exactly what it does. But the first thing that we just want to make some observations that you should remember for when you're actually using JavaScript. The first thing is that every statement in JavaScript ends with a semicolon. And you can see at the bottom, const x equals 50 and const y equals 15. Both of those end in a semicolon. The next thing to know is that in JavaScript, unlike Python, which you might be coming from, whitespace is ignored. So whitespace being like excess spaces, new lines, or indents. Technically, you can have this entire function, this entire block of code here. You could have it just be on one line. It'd be very hard to understand, but it would actually do the exact same thing. Another thing to note is that JavaScript uses curly braces to denote blocks. So you'll see these curly braces all over in your code, and that's just where blocks begin and end. And the last thing is that JavaScript, like many other languages, has comments. And so these don't affect how your code will run, but you should use these to like keep your code base readable. So if you have some code that is like pretty hard to understand, you can include a comment that explains what your code does. So if someone's reading your code later on, or if you're just reading it yourself, then you don't have to spend an hour trying to understand, like decipher what the code is doing there. All right. So the next thing that we're going to talk about is how you're going to define variables in JavaScript. The first way that we're going to learn this is via the keyword let. And what let does is it tells JavaScript that you're defining a variable here. So the first line I'm doing let my Boolean equals true. So I'm giving the variable my Boolean the value true. And then the same thing for my number and my string. And then what's pretty nice about JavaScript is that you can reassign a variable later. So I set my Boolean to be true initially, And let's say later I run some code, I decide I want to change my Boolean to false. I can use like similar syntax to change the value of my Boolean. So I do my Boolean equals false, except the only difference this time is that I'm not using let again. So you only use let when you're defining a variable for the first time. And in JavaScript, the convention for naming variables is camel case. It's named like that because you just have everything capitalized except for the very first word in your variable name. And so this kind of looks like a camel where the uppercase letters are humps of your camel. And then the one at the very beginning is also lowercase. Well, another way to define a variable is via the const keyword. And so what this does is it defines a variable that can't be reassigned later. So say I write this line of code here, const answer to life equals 6.148. What that means is that answer to life will pretty much forever be bound to the value of 6.148. So if I try to reassign answer for life later on, I will actually get an error. So I can't actually reassign it to 42. Okay. And so now that we've learned two different ways of defining a variable, you might be asking yourself, like, why would you ever use const over let? Because const is kind of like limiting what you can do with a variable. And the reason for that is like let and const, or const is like good for safe code practices. So if something should never be changed, you want to make sure that actually doesn't change. And the way you do that is by defining it using const. So for example, if you have like a conversion factor like seconds per minute, obviously you're going to want it to be 60 and you're never going to want it to change because if this changes at some point, you're going to have some big issues other than just trying to change the numbers. Then earlier I mentioned that null and undefined are two different things, and I'll explain what they are now. So when you first declare a variable without giving it a value, it's undefined. So in the block of code here I have, I'm writing let first name without setting it equal to something. So I'm not assigning it to anything. So if you asked JavaScript right now what first name is, it would give undefined. So then let's suppose later I go on and I assign it a value. Now first name has been assigned a value. It's now a string. And then say I want to delete this variable later. So I want to explicitly tell JavaScript that first name should not be anything anymore. I would assign it to null, which means that there's no more value. So you're just using null to empty a variable, and you're using undefined to denote a variable that hasn't been assigned yet. So that's the difference here. And if you've used JavaScript before, if you've seen it online, you might have seen var. And you might be wondering what the difference between let and var is. The short answer is just don't use var. And I guess like the long answer is that var was originally in JavaScript without let, and then let was added on later because people who were coming from different languages would use var, and it would produce like unexpected behavior because of the way that var is function scoped, let is block scoped. You don't need to know what that means. But if you're coming from a different language, you should just know that let will let your variables behave how you expect them to. And if you use var, you're going to run into pretty weird bugs. And when you're writing code, oftentimes you're going to want to produce output. In JavaScript, the easiest way to do that is console.log. And so what this pretty much does is it will just print whatever you put in the parentheses into the console. And so this is pretty similar to like system.out.println or print in JavaScript. This will just print something to where like the programmer is meant to see it. And it's pretty useful for like quick debugging. So say I had this set of code here, and I want to make sure that it's doing the right thing. So at the end of all the operations I do on it, I'm going to put the line console.log, and then it should actually print out 70,000 here. And then so I should be able to verify where my code is doing the right thing and where it's doing the wrong thing by adding console.log statements. All right. And then the second way that we're going to learn how to do output is via alerts. And so the alert function will generate a pop-up notification with the given content that's between the parentheses. So if I do alert and then in quotations, congratulations, it'll create this pop-up on the web page that says congratulations. Great. Are there any questions? Yeah. Yeah, so console.log, it just writes whatever you put inside of the parentheses to the console. So I mentioned the console earlier is like where you can write code, and every browser has a console which you can access by doing the shortcuts I showed earlier. And then so if you have a console.log statement in your code, and then it's run, it'll actually print out to the console, and you can see where it was printed there. So it's useful for output, for like debugging in most cases. Do you have any other questions? All right, let's move on. So we haven't really talked about like what you can do beyond the primitives in JavaScript. And like the first thing that we're going to learn, like a first more complicated data structure that we're going to learn is an array, which is where you can like store a sequence of items. So for example, here I'm creating an array that stores 4 different strings, and I'm calling it pets. I'm assigning it to the variable pets. And you denote an array in JavaScript via these like square brackets here, and then you separate each item with a comma. So that's the syntax for arrays. And what you can do with arrays is you can access the elements that you've put inside of the array. So say I wanted to print out the 3rd element of my array here. I would go ahead and I would do console.log, which would print out to console. And then pets, which is the name of my array. And then in square brackets, I would put down the index, which is like the position of the item in my array. So in this case, I'm taking the 3rd element out of the pets array. And if you haven't like done programming before, if you haven't seen this before, you might expect guinea pig to be printed out because it is the 3rd element in the array. But JavaScript, like many other programming languages, is actually 0 indexed, which means that cat is not the 1st item in the list. It's actually the 0th. So cat is the 0th element, dog is the 1st, guinea pig is the 2nd, and bird is the 3rd. So what actually gets printed out here is bird. And then another thing you can do with an array is that you can replace elements. And so just like how I was printing out pets and then just putting the element that I want to use in square brackets, I can have that on the left-hand side, like as if it were a variable, and then I can assign it to a new value here. So after I run this line here, the array becomes cat, dog, hamster, and bird instead of guinea pig. All right. Another thing that you can do with arrays is that oftentimes you're going to want to like remove or add to the end of your array. And the 2 functions for doing that is pop and push. So what pop does is that it removes the last element from your array. It just cuts it off. So if you call pop on the pets array, then you're just going to get rid of bird. And you can also add to the end via push, and then just do pets.push, and then you put whatever you want to add in the parentheses. Great. So oftentimes when you're writing code, you're going to want to like have your code produce different actions, like in response to different conditions. So this kind of reads like English in that, like, say you want to run something if a condition is true. So in the case of this block of code here, what happens is that if hour is less than 12, then you're going to run this block of code denoted between these curly braces here. And so if hour is less than 12, you're going to print out good morning. And then if that's not true, else, then you're going to check is hour less than 16. And so this should like make pretty intuitive sense. So you're just going to keep running down these checks until you find one that matches, or you're going to reach the else statement, which is kind of like a cat all for if none of the above checks are true. And if you're coming from a language like, if you're coming from Python, there's going to be a bit of like a difference here. Else if in Python is combined into one word, elif, but in JavaScript, it's just 2 different words. You just have to remember that. Great. And note that like the indent, I've put an indent for every block. it's not actually necessary. Like I mentioned earlier, white space is ignored by JavaScript, but it definitely makes your code more readable and much more cleaner if you include them. All right. So the next thing that we're going to talk about is a while loop. So this is useful if you want to like repeatedly run a code for many times, as long as like some condition is satisfied. And the way that you do that in JavaScript is as follows. So suppose I have this bit of code here, and I'll give you a second to read it. But what it's doing here is it's actually printing out powers of 2, starting from 2. So we're saying, so let me run through it real quick. So we're saying z equal to 1, and then we're checking the statement right after the while keyword. We're checking is z less than 1,000. If that's true, then we're going to run the block of code inside. And then once we're done running that block of code, we're going to go back up to the top of the while loop. And we're going to check if this statement is still true. If it's still true, then we're going to run through the block of code again. So what happens when you run this block of code here is that it prints out from 2 to 1024, the powers of 2. And you might be wondering why 1024 is printed out here. And the reason for that is that on the very last iteration of this loop, on the last time we're going through this block of code, z starts out as being 512. So when z is the first thing you do inside the loop is you're multiplying z by 2. And then you're printing, so then you get 1024, right? But you're not checking is z less than 1,000 until you finish the block. So you're going to print out z is equal to 1024 before you go back and check is z less than 1,000. And it's only then that you're going to break out of the loop and you're going to stop running. You're going to stop printing out more values. The next way that we can iterate through something is via a for loop. And this is probably more common. You're going to see this pretty often. So say I wanted to go through all of the elements of my pets array. So I wanted to print out, I love my cat, my dog, my guinea pig, and my bird. And the way that we're going to do this is via a for loop. And the syntax might be a bit daunting at first, but we can go through it part by part. So the first thing that you're going to want to do is you're going to write down the for keyword. And then you're going to have in parentheses, you're going to have 3 pieces. So you can see the 3 pieces are separated by these semicolons here. And so what the first piece does is it initializes kind of like a counter variable for my for loop. So I'm setting I is equal to 0 in the very beginning of my loop. And then the second chunk here is kind of like the while loop, where I'm iterating through this block of code here if that statement is still true. And then the last bit of code here is I++, which if you're coming from some other languages, it might be foreign. And this is just shorthand for I equals I plus 1. It's just incrementing I by 1. It's a nice shortcut that JavaScript has. So what this for loop does is it sets I equal to 0 in the very beginning. And while I is less than the length of the pets array here, it's going to run the block of code. And at the end of the block of code, it's going to increment I by 1. So what actually gets printed out here is I love my cat, my dog, my guinea pig, and my bird. All right. Yeah, so the next thing that we're going to talk about is a different type of for loop. In this, if you're coming from Python, might be more familiar. It takes the form of for blank of blank. And what this means is if we take a look at the example here, I'm doing for, and then in parentheses, I'm doing const animal of pets. So what's happening here is that it's assigning animal to every element in pets. So animals can be cat for the first iteration of this loop, and then it's going to be dog, and then it's going to be guinea pig, and then bird. And like before, or actually, a difference between JavaScript and Python is that this for loop, this structure of for loops requires the keyword of instead of in. So if you've done a lot of Python, you might be used to writing like for I in range, whatever. You have to like forget that muscle memory. You have to remember to type of instead of in. And so this, this for loop here actually does the exact same thing as the last one. But just like a bit of a word of caution is that in general, you're not going to want to use this for loop structure because the regular for loop, the one in the last slide, it does everything that this for loop does, but it does everything that you ever want to do with a for of loop. And like this syntax is kind of just like another thing to remember, and it might be confusing if you use in instead of. So in general, I'm going to recommend like you not use this, but I'm telling you about this just in case you ever see this like in the wild on the internet and you don't know what it does. And like another word of caution is that if I did write like for const animal in pets, like JavaScript will accept this syntax, but it'll do something totally different from what you expect. So if you get used to writing, if you want to write for loops in this syntax, then you might run into like the error where you write in instead of, and then you're going to have another like bug that you have no idea what caused it. So in general, just try to, I'd recommend that you just try to use the regular for loops. Okay, let's take a break for questions. Yeah.
In the for loop, why do we use constant animal?
Oh yeah, good question. So one thing about blocks of code, so denoted by the curly brace, is that things that are defined inside the block, they only like live in your program for as long as that block is being run. What I mean by that is like when I'm defining const phrase, right? When I first run through this block of code, phrase only exists like in my program for 2 lines. It exists for this first line of the block, and then it exists for this one. And then once we go out of the block, when we go back to checking, we go back to our for loop, phrase is like kind of deleted from your program. So in that sense, that's why you're allowed to use const here. That's why you're allowed to use const here, because it's just going to be redefined every time. And because you're only actually writing it once in your code, you're allowed to use const here. And for const animal, even though it's like put before the block, the way that JavaScript like treats this is as if you defined animal inside of your block. That's why you can use const here. Yeah. Yeah, so it is like technically changing, but like I said, animal only lasts for as long as the block is around. So like when you run through the block of code, animal is only existing within that block of code. So once you exit it, animal is like deleted from your program. And so like when you go back to reassigning animal to another value, it's kind of like as if you're starting from another blank slate without animal. So, right, so it's just like as if you're assigning animal for the very first time every time you go through the block of code. Any other questions? All right. Let's move on. So the next thing we're going to talk about is functions, which are common to very many programming languages. And what they do is they take a couple inputs, and then they do something with that input. And in WebLab, we're going to be using this syntax for functions, which is called like the arrow function notation. And the way that you do it is you have, in parentheses, you have your parameters, which are like your inputs to your function. And you have like this cute little arrow, which is just an equal sign, and then the sideways caret. And then you're going to have the body of your function in curly braces. And so I have an example of a function here. What this function does is it takes a Celsius temperature, and then it returns the same temperature in Fahrenheit. And if you'll look at, one thing to note here is that if there's only one parameter, you can like drop the parentheses around the parameters. So I said the syntax was like parentheses around the parameters, but if you only have one, you don't need it. And then if we run this program, so like the way to actually call the function is you give the name of the function. In this case, I'm assigning the function, which starts at temp C. So like this bit of here, I'm assigning it to the name Celsius to Fahrenheit. And then the way to call the function is to write the name of the function, and then in parentheses, I put your input. So I'm doing Celsius to Fahrenheit, and in parentheses 10, which passes in 10 as temp C, and then temp C is run through the program until you get to the return statement, which is what the function will evaluate to. So in this case, writing console.log, Celsius to Fahrenheit 10 will produce the output 50. And the actual value that we give to the function is called an argument. So in this case, 10 is the argument to our function. And the last thing to note is that functions are kind of treated like other variables in that, or like other data types in that you can assign it to a variable. So if you look at like the syntax of functions here, you'll know that temp-c is actually where this red syntax begins. And then I'm pretty much just taking that entire thing, which is a function, and I'm assigning it to Celsius to Fahrenheit, a variable. And so like this brings up the idea of like being able to pass the function around like any other variable. So what I mean by this is you can give a callback function, a special type of function called a callback function, as an argument to another function. So this is like kind of like function inception, where you're just like having an input to another function be a function. And like the question that you might be asking is like, why would we do this, right? And I'm going to walk through an example of how callback functions can be useful. And so suppose we have this really simple function here called add2. And all it does is it takes an input and it just returns that input plus 2. That's really simple. And then, oops. And then now we have this other function called modify array. And it might look a bit daunting at first, but I'll walk through what it does. Is it takes in an array, it takes in two inputs. The first one is an array, and then also takes back a callback function. And then what it's doing is it's going into the array, and then it's like calling this callback function on every element in the array. So it's like applying the function on each element and then resetting and then reassigning each element in the array to like what the function did to that element. So what happens is if we have my array equals 5, 10, 15 to 20, we can call modify array on my array and add to the function. And then what happens is my array afterwards is going to be 7, 12, 17, and 22. So it's modify array, all it's doing is it's taking in an array and it's applying the other input, the callback function, on every element in the array. In this case, we're just adding 2 to every element in my array. All right, let's move on. So because callback functions are like going to be really important for like the rest of the class, like starting today, I'm going to go through like a really common mistake that we often see with callback functions. So in the previous example, we were introduced to add2, like the function. So add2 by itself is the name of the function. Then if you do add2 of x, where you put x in parentheses, that's the actual value that you get when you run add2 on x. So what we often see is this thing at the bottom here, where you're calling modify array, but instead of you're calling it on add2, you're calling on it on add2 of x. So like this might like look correct if you're coming from like a mathematical background where functions are always like f of x. But what's really happening here in this block of code at the bottom, or this line of code, is that you're calling modify array on add2 of x, which means that you're running add2 on x first, and then you're taking the value that gets returned when we run add2 on x, and then you're passing that in as the argument. When instead you just wanted to pass in the function itself. So the way that you want to do it instead is you want to just give the name of the function. All right. Cool. So if we look at the example of code from before, you'll notice that, as I said before, like this is like the actual function part of the code of add2. And you can see that we're taking this function and then we're assigning it to add2. And then we're using it once. We're just like using it once at the very bottom. And then the question is like, do we actually have to go through all the trouble of, creating our function, assigning it to a variable, and then using like that variable name in like somewhere else if we're only using it once? And like the answer is no. You can just like go ahead and do what's called an anonymous function. And then you can cut out like the middleman of naming and then using the name. You can just directly use your function where you're going to use it. So in this case, if you look at like the piece of code that's highlighted, it's the exact same thing as what I'm assigning to add to here. I'm just moving that bit and I'm putting it right where I'm going to be using it. And what this does is like, I don't have to go through the trouble of naming my function. And like, it's just right there where I need it. So your code actually becomes more readable and is actually easier to understand this way. And it also looks cleaner when you don't have to like have a bunch of variable names if you don't actually need them. And in the case of this function here, if your function is like simple enough, so for example, if your function only uses one statement, like only one statement in the body, you can like simplify your function by using the following shorthand. So instead of doing parameters, arrow, and then like in curly braces, your body, if your output statement is only one statement, like if your body is only one statement, you can just cut out the curly braces and you just have it directly there. So like this like looks really clean. So add to can really be simplified to just x, arrow, x plus 2. And so that has the exact same meaning as what we've known add to do, but it just looks a lot simpler, it's a lot cleaner, it's easier to understand. All right. And earlier I mentioned that, that arrays, like we're going to want to do a bunch of different things with them. So the general rule is like if it seems common enough, like something that you want to do with an array, there's probably a built-in function for it. So we've already seen like push and pop, which mutate the target array, which like they just move one and add one to the end of the array. What else we can do is these two functions I'm going to introduce now is map and filter, which will produce a new array based on some instruction. And that instruction is going to be a callback function. So let's get into it. First one that we're going to talk about is map. And what this does is it creates a brand new array by applying the callback function to every element of the starting array. So this is really similar to like our modify array function, except instead of like modifying the input array, we're just spitting out a brand new array with this one. So if we look at the example here, we have my array, which is just 1, 2, 3, 4, 5. And then if we call my array.map, and then we give it a callback function here, x is mapped to x times 3. Then it's going to produce a brand new array that's 3, 6, 9, 12, 15, which is every element of my array times 3. So you can think of this as it's really just mapping everything in one array to a brand new array. If that might make more sense if you're coming from like a mathematical background. And for like a bit more of a longer example here, if we take the Celsius to Fahrenheit function that we used earlier, we can take an entire array of Celsius temperatures, and then we can turn them all into Fahrenheit temperatures all at once by just using the .map function. And it'll produce an array of Fahrenheit values. All right. And you can find all these online. You don't have to write everything I'm talking about down. So the next thing I'm going to talk about is filter, which is filter is a way to, it also creates a new array, but it kind of like filters out the bad ones. It like only selects the ones that we evaluate as good. And the way that we evaluate a element as good is via another callback function, which returns a Boolean. So for example, if we have this values array here with positive and negative values, and we decide that, non-negative integers are actually everything greater than 0 is good. Everything that's not that is bad. Then we can pass in to filter. We can pass in if the check is x greater than 0. And then everything that fails this check will just be cut out of the array. So we're going to produce a new array 3, 2, 4, which cuts out -6, 0, and 9. Oops. And then the same thing for, you can do a similar thing for the second example, where like, say I have a list of the staff, and it's kind of corrupted in that there's some bad names. meaning like there's just some empty strings in there that we don't really necessarily want. They're just clogging up space. And the way that we can get rid of those is that we can use filter, and we can just filter out the ones that are empty string. So if name is not equal to an empty string, that means that it's good, then we keep it. Otherwise, if it's equal to empty string, then we get rid of it. So we end up with just a cleaner array here. All right. Any questions, comments, concerns? I guess we're good. So the next thing that we're going to be talking about is, wait, we don't have a primitive data type for this. And so what is this? This is a car. And so, right, so we have a car here. And besides that, what do we know about this? We know that there's like a make and model for this car. It's a Ford GT. And we might also know that it's like its color is red and stuff like that, right? But we don't have like a way to combine all these different facts about one object into one variable. So like, for example, we want to have one variable that stores all the relevant information about this car that we have here. And the way that we do that in JavaScript is via objects. So a JavaScript object is just a collection of properties. And a property is just like a name, which is like the name of the property, and paired with a value for this object's property. So for example, I can have an object here. If you look at the syntax, it's defined by these curly braces. And then inside the curly braces, I have these name value pairs, which are separated by commas, and the name and value have a colon between them. And so what's happening here is I'm just having an object that has the properties make, model, year, and color. And then the make, when I try to evaluate it, is for the models Mustang and so on, right? And if you're coming from Python, this is like a very analogous to a dictionary. So you're just taking, you're just keeping a collection of name and values. Right. And so what can you do with an object? The main thing that you'd want to be doing is accessing properties. So there's two ways to access properties if you know like the property name. So say I wanted to get the model out, I can do it with mycar.model, and it would return Mustang. So it's like the value of the property. And then if you're coming from Python, you can also do it via like these square brackets. And then you just put the name of the property in between your square brackets as well. And these two ways of accessing the object properties are the same. You like generally just like choose one that makes more sense to you. There's no difference beyond like what they look like in your code. And sometimes you're going to want to like take out multiple properties of an object at once. And there's like a shorthand for that. So say I wanted to, if we go back to my car, like the example of my car, I want to take out the make and the model at the same time. And I have like two lines here that are kind of like, they look kind of redundant because they're doing practically the same thing. We can use object destructuring to like shorten that to just one line. And this syntax here uses just like these curly braces, and I'm just taking out the make and model. It does the exact same thing as the block of code on the left. It's just a way to make your code, cleaner, makes it more readable. And like, if you can do this, we generally recommend that you do this. And you're probably also going to see this a decent amount later on when we get to React, like this object destructuring syntax. All right. So next, we're going to talk about how we can use objects. So we can treat an object like any other variable. So we can like kind of put them in an array here. So we have let my cars be like an array of car objects. And so we can act on them like any other variable. So say we wanted to filter out the ones that are red, we can do that with just doing red cars equals my cars filter and so on. Cool. So I mentioned earlier that, well, actually, let's talk about this first. So in JavaScript, when you want to check equality, we use triple equal signs. And like these kind of work like how you expect. 2 is equal to 2, 2 is not equal to 3, string 2 is equal to string 2. And then you get to like this last example here where the number 2 is not equal to string 2. And like this makes sense because the number 2 and string 2 are actually different data types. And so you don't necessarily want them to be equal. Like you pretty much never want them to be the same thing. But let's talk about like what does equal mean for arrays and objects. And let me just pull up the console so we can see this. So let's say I have an array 1 and I'm setting it to 1, 2, 3. And then 2 equals 2, 3, right? So I have these two arrays here and like they look the same and like you'd expect them to be the same, right? But if I tried array 1 is equal to array 2, if I ask JavaScript this, it's going to say false. And that might be surprising, but if you're coming from a different language, you might understand what's happening, but I'll talk about that in a second. The same thing goes for objects. If you have like what looks like the same object here, person 1 should be the same as person 2. They're actually different objects. And the reason for that is that when we have an object variable, they're actually just references. So they only point to where the data is actually stored. What I mean by that is in this line of code here, let person 1 equals an object with the property name is Bill Gates. What it does behind the scenes, what JavaScript does behind the scenes, is that it first creates the object. Like it puts it somewhere in memory. And then it might forget like where this object is in the future, right? So what it does is it creates a different object in your memory, which will point to which will tell like JavaScript where this object is. So it creates like, so like your variable person 1 is not actually the item that you're assigning it to. It's just a pointer that tells you where this item is. And then so when you run the second line of code, you're creating a new object, also with the same properties. And then you're assigning person 2 to that other object. And so there are like two different things in memory, these two objects, and you have just two different variables pointing to the two separate things. So in JavaScript, the triple equal signs will check if the references are equal. So they'll check if person 1 points to the same object as person 2. And because they're created separately, they're going to be false. They're not going to be equal. And the same thing will go for arrays, that two arrays created separately will have different references. And so oftentimes you're going to want to copy an array or an object. And it's not as simple as this. And I can demonstrate again. So let's do that. Array 1 equals like 2, 3. Right? And then let's say let copy array equals to array 1. Right? The issue here is like, sure, if I print out like copy array, it's going to give me 1, 2, 3, like I expect. But the issue is if I change array 1, array 1's like, let's say I change the first element in array 1 to be like 5. And then now I print out array 1, like this is all fine. It becomes 5, 2, 3. But now if I try to print out copy array, it's also 5, 2, 3. And so this is an issue because we wanted to create a copy of array 1 so we can like probably freely do stuff to the copy or freely do stuff to array 1 without affecting the other. But in this case, also let me make this bigger. So in this case, like we've run into an issue here. And how do we fix this? So how do we actually copy in JavaScript? And the way that we're going to do it in this class is we're going to use the spread operator, which is just 3 periods. So if we want to create the copy of array, we're going to do in square brackets, we're going to use ... And then we're going to have the name of the array that we want to copy. And then a similar syntax goes for object copying. And for reference, why the top example didn't work, it's because copy array and array were actually two references to the same object. And that's the reason why when you changed one, you would also change the other, because they were actually just modifying, they were actually like pointing to the same object. So if you modified one, the other one would just see the same change. And so like we use a spread operator because it's like really clean. You could obviously go off and like create a brand new, like you can create a brand new object instead and copy all the properties one by one. But that would be like not very good coding practice because it would just be a lot of extra code for no reason and it would just be no fun for you. So we use a spread operator. Okay. And then I mentioned earlier that we use triple equal signs to check equality in JavaScript. And you might be wondering why we don't use double equal signs, because it also exists in JavaScript. But I'm going to give an example of why we don't actually use the two equal signs and we always use triple equals. So like let's first look at the behavior of triple equals. 2 is equal to 2, that's obviously true. Is 2 equal to number, or 2 equal to string 2, that's false. But if we try to do that with double equal signs, we get true for both of them. And the reason that double equal signs would also evaluate this to be true is because it performs type coercion. So what that means is when it's comparing two objects of different types, it's going to try to force one of them to be the same type as the other. So instead of comparing 2 with string 2, it's going to compare like string 2 and another string 2. It's going to turn the first one into a string. And then that's why they would be true. So TLDR, don't use double equal signs, always use triple equal signs. All right. Then the last topic I'm going to go over is classes, which allow you to have like multiple entities that have the same exact behavior. So in this case, I'm creating a rectangle class, which has width and height. So each rectangle will have its own width and height. And every class will have a constructor, which tells you how to create a specific instance of rectangle. So if you look at the code down here, small rectangle equals new. New is like a keyword that denotes that you're creating a class here, a new instance of a class. And then we're giving it a width and height of 3 and 4. And then you can also do that again for a different rectangle, and you can give it like different inputs as a rectangle. And then so if you wanted to see like what the small rectangle's width was, you can print this out. And I'm going to rush through this part a bit because classes are a really large topic in that I can't like ever hope to cover everything that you're going to need to know about classes in such a short time. Because like classes are so complicated that you can definitely just have classes that are devoted entirely to learning about classes. But yeah, so some things that might be useful are to note like classes have instance properties. So the rectangle example from before, each rectangle had a width and a height, and you access those via, like if you're inside the class, you would access those via this dot your property name. So this get area method here, it'll return the area of the rectangle, which accesses its width and height by this dot width and this dot height. And so classes may contain methods, which you might be familiar with if you're coming from a different language, that will be able to manipulate the class that it's in. Great. So let's get to a quick summary. We learned today about how like JavaScript is how we make things happen in a website. JavaScript is like, it's a programming language more like that you might be used to. It's kind of like the logic handler, everything, like all the cool programming stuff part of your website. And we learned how to declare variables using let and const. And we learned the 5 primitive data types of JavaScript. We also learned some more like complicated data structures like functions, arrays, objects, and classes. And we also learned some control flow methods, which is the way that like different the way to like run code differently every time it's run. We learned if, else, while, and for. And that's it for this one. And up next, we're going to have a hands-on JavaScript workshop. Cool. Any questions? Yes.
What does the new keyword do?
So new is used whenever you're creating an instance of a class. So new is just used when, yeah, so like when you want to create an instance of a class, it just means like a class, like when you're writing in code, class, whatever, that's just like a structure, right? When you're using new and then the class name, you're creating an actual like instantiation of that class. So that's the thing that like the instance is what you can manipulate. You can do all your fun stuff with. Yeah. Sure. Using objects. Oh, I see. Mm-hmm. Do you have any other questions? Also, feel free to use the questions doc. All right.